Okay, we're going to work on our new assignment, find growth and decay percentages. Now what that means is we're going to work backwards. So you're going to have to try to determine, is the equation they're giving you a growth equation or a decay equation? And once you figure that out, you need to figure out its rate of change. In other words, what is the percent that it was increased, or what is the percent that it decreased? So a couple of things I want you to remember. First of all, in a growth equation, remember our B is the population plus the rate. That means we're going to take our whole population and we're going to add the rate at which it grew. Now remember, if we take 1 and we add a number to it, then we know that B is always going to be greater than 1. It's going to be greater than 1.0 because we are starting with 1. We're starting with the 1 and we're adding something to it. So it doesn't matter how small that rate is, it will still be larger than 1. Now, in a decay equation, we have A times 1, our population, minus the rate, because remember, it is getting smaller. Now, if we take a 1 and we subtract the rate, then we know that our answer here is always going to be less than 1. It is going to be less than 1 because we are starting with 1 and we're taking something away from it. It does not matter how small what we're taking away is. It will always be less than 1. So when we take a look at our equations, if it is greater than 1, then we know it is a growth equation. If it's less than 1, then we know it is a decay equation. So let's use that information and start to find some solutions. Okay, so in our first one, it says, given the following exponential function, identify whether the change represents growth or decay. And, notice we have to do two things, and determine the percentage rate of increase or decrease. Okay, so we just talked about the first part. I'll help you with the second part. So notice that we have an equation here. Y equals 940 times 1.89. So let's take a look at this number right here, 1.89. Is this number greater than 1 or less than 1? 1.89, that is greater than 1. So that means this is a growth equation. Equation. Now what that means is over here, you're going to select this button and make sure it says growth. Now we have to find the percent of increase. Now remember when we were working on these equations and I said it was really important for us to do something with that in between the parentheses number. So what I want you to take a look at here, I want you to remember in a growth equation, we write 1 plus r. That means that 1 plus something equaled 1.89. What was added right here? If I started with 1 and I added something and I got to 1.89, what did I add? Well, what we can see is that we added this piece right here. We added the 0.89. Right? Because 1 plus 0.89 is 1.89. Now remember, they are asking for the percentage rate. So they want a percent. So we have to work backwards again. Since 0.89 is the decimal form, we need to turn it into a percent. And we turn it into a percent by multiplying by 100. Now when we multiply by 100, what ends up happening is we move our decimal twice. So we end up with 89%. So on my answer document here, I would type in 89%. So there's our answer. We would submit. Okay, let's take a look at number 2. Now, in this second one, let's go ahead and read through it and see if it's a growth or decay. Given the following exponential function, identify whether the change represents growth or decay and determine the percentage rate of increase or decrease. Okay, notice I have y equals 58 times 0.76 to the x. Now, let's go ahead and take a look at this number right here. 0.76. Is this greater than 1 or less than 1? 0.76, which is 76 hundredths. 76 hundredths, that is going to be smaller than 1. It is smaller than 1. And remember, if it is smaller than 1, then we know that it is a decay equation. So that means over here, we are going to click the buttons and we're going to make it say decay. It is shrinking. Our population, represented by this equation, is getting smaller. Since it's getting smaller, we're going to use our equation for decay. Y equals 58 times 0.76 to the x. But remember, this is 1 minus something equals 0.76. So I almost want you to think of $1. If this is $1 and I've taken away something and I have 76 cents left, how could we figure out what goes inside this box? If I have $1, I take something away and I'm left with 76 cents. Now, we can kind of use what are called fact families to solve this. If I have a 1 and I take away 0.76, I am going to equal that same value that goes inside this box. So, oops, there we go, inside this box. So there's more than one way to write this. So notice here, I can find this number out by rewriting my equation into a format that I recognize better. So now I have 1 take away 0.76. So a couple of different ways. Sometimes I start at 0.76 and I count up to 1.0 and I would get 24 cents, right? Because 0.76 to 0.8 is 4 cents, and then 80 cents to $1 is 20 cents, so that's 0.24. I don't know if that helps you guys, but I jump. This is how I kind of add and subtract. I actually do adding by counting up. What you can also do is take your $1 and take away your 7.76. Now this one's a little bit trickier because you have all this borrowing to do, but you're welcome to do that. Whatever method works for you. Oops, 9, 10. So then I get 4 and I get 0.24. The important thing is that we find out that this is 0.24. And since it's 2.24 here, it is also 0.24 here. So now we have found out that it is decaying at a rate of 0.24 or 24 hundredths. Now remember, they want percentage rate. Since this is a decimal, we need to change it into a percent. So I change it into a percent by multiplying it by 100. And what that means is, if I do the work, it moves my decimal 2 times to the right and I get 24%. So it is decreasing by a rate of 24% per, I don't know, it doesn't tell us, per year, per minute. So make sure you understand how we are finding out, first of all, whether it's a decay or growth. And then we have to find out that percent of change. Okay, let's take a look at our next one. Okay, in this one, again, I have y equals 250 times 1.904. That's 1 and 904 thousandths. Now, we have to decide, is this number more than 1 or less than 1? Hopefully you figured out it is more than 1. And since it is more than 1, then we're going to keep this growth. Now we have to figure out how much it's growing by. So y equals 250 times the 1.904. And remember that this is the equation 1 plus something equals 1 and 904 thousandths. So in other words, what did they add to the 1 to get 1 and 904 thousandths? Well, what they did is they added the 904 thousandths. So we now know by how much it's growing. This is a percent. No, sorry. This is a decimal, and we need a percent. So 0.9404, we times that by 100, which means we will move our decimal 2 times. 1, 2, and we have 90.4%. So that is the number that I type in here, 90.4% increase. That's almost doubling. Okay, one more. Okay, in this one, my equation is y equals 52 times 42 hundredths to the x. So we need to determine, is this a growth or a decay? I want you to think about it. If you need to look up at the top, look up at the top. Remember, 0.42 is less than 1. It is less than 1. And if it's less than 1, it is a decay equation. So we know this is decay. So over here, we have to switch this to decay. That means our population's getting smaller. So in order to find out by how much it's getting smaller, we need to do some work with our equation. So 52 times 0.42 to the x. Now remember, they find this 0.42 by taking 1 and subtracting something. Let me get rid of that piece. That's going to bug me. There we go. 1 minus something equals 0.42. So again, think of money. If you start with $1 and you subtract something and you get 42 cents back, how much did you subtract? So I want you to think about this. If I start at 0.42 and I want to know how to get to 1, I'm going to count up 42 cents up to 50 cents is 8 cents. I had to add 8 cents, right? From 42 to 50. And then from 50 cents to $1 is I have to add 50 cents. So that means that I've added 58 cents or 58 hundredths. And since 58 hundredths goes here, that is my amount of change. Now, if this up here doesn't make sense to you, let's go ahead and show you another route. Remember, you can just take your $1 and you can subtract your 58 cents. Oops, sorry, not 58 cents. Oops. Minus your 42 cents. And again, you still have to do a lot of borrowing, so if it's easier to count up, you can count up. And then I get 5. Okay, so now that we have 58 hundredths, remember, they want a percent. So I need to multiply by 100, which is another way of saying I need to move my decimal twice to the right. 58%. So I am going to go ahead and write 58%. This actually changed to decrease. When you change growth to decay, this will change to decrease, just so you know. And then you hit submit. Okay, if you have questions, make sure you ask during class.